Welcome to today's webinar entitled Defining Rigless and Rig-Based Decommissioning. I'm Andy Norman and I'm the Brand and Marketing Manager for Claxton, your webinar organiser today. Today's presentation has been developed after receiving a number of direct requests asking us to cover a topic in decommissioning. As operators are now under increasing pressure to reduce costs, the focus on decommissioning has now become that much greater. The scale of cost reduction required means looking beyond immediate short-term efficiencies and thinking more strategically of ways to reduce costs in the long term. The content of this webinar will describe some of the decommissioning projects Claxton has been involved in over the past 20 years, as well as providing you with a summary of the processes and procedures that we can offer to abandon your wells reliably, successfully and safely. Before we start, just to note, we won't be taking live questions today. However, there will be an opportunity after the session to submit any questions to info@claxtonengineering.com. Okay, I would like to introduce you to Tom Mason, today's presenter. Tom is the Senior R&D Decommissioning Engineer at Claxton and has been with the company for just under 4 years. Tom started his engineer career as an apprentice for a family-run company and was trained by an ex-Marconi toolmaker who specialised in the restoration of military vehicles for the Imperial War Museum. After gaining a Bachelor of Science Honours degree in design at the University of Brighton, Tom turned his attention to heavy engineering, working as a design engineer for Kukuric excavators. In his time there, he designed bespoke front-end equipment and modified hydraulic excavators for the demolition industry. Tom has worked on some of the largest demolition machines in the world, weighing in at 230 tonnes with attachment working heights of 65 metres. And before joining Claxton, he worked in the defence industry for Marshall Specialist Vehicles in Cambridge, designing and adapting integrated vehicle systems for both the military and civilian sectors. Since being at Claxton, Tom has primarily been focused on Sabre, which is Claxton's proprietary abrasive cutting system. He has been heavily involved in the development of the latest generation Sabre 3 garnet mixing system and subsequent deployment equipment and tooling. I'm therefore pleased to introduce you to Tom Mason.
Thank you, Andy. As Andy mentioned, in recent years, decommissioning has come to the forefront of the minds of the people who not only operate in the North Sea, but globally within the oil and gas industry. The compounded effect of aging fields and infrastructure, with the unprecedented drop in the price of a barrel of oil, is hitting operators hard. We are seeing more and more of our clients seeking to reduce their asset stock whilst remaining profitable at the same time. So it has never been more important for clients to have a reliable and expert supply chain to rely on for guidance and support. The purpose of this webinar is to give you an overview of the main services offered by Claxton and how we can assist you with the planning stages and implementation of your decommissioning projects in the most economical and cost-effective way possible. Claxton's decommissioning services essentially fall into two categories, which are rigless decommissioning and rig-based decommissioning. So today's agenda will cover the following: rigless decommissioning, which encompasses platform well abandonment and subsea well abandonment, and rig-based decommissioning, which will cover drilling rig-based abandonment and simultaneous operations. And we'll finish on a summary.
So what is rigless decommissioning? Not requiring intervention from a drilling rig. Obvious really. However, what people are not aware of is that Claxton were involved with the world's first ever rigless platform well abandonment campaign on the Esmond, Forbes and Gordon fields over 20 years ago. At Claxton, rigless well abandonment encompasses both platform-based wells and subsea wells, for which we have extensive experience, proven across multiple offshore campaigns since the days of Esmond. For both types of well, a drilling rig is not required to be brought in. For platforms, Claxton can provide our bespoke modular recovery system and work platform, which can be tailored to suit the particular deck layout of the installation. Whereas with subsea wells, we operate from a deck of an anchor handling towing support vessel or light construction support vessel. It is worth noting this is a general overview of the stages involved. Each well abandonment program would be fully assessed on a case-by-case basis, and it's also assumed that the well is not live and has been plugged at the reservoir in accordance with industry regulations. So what are the typical stages of platform well abandonment? P&A. So if remaining intermediate or surface plugs are required, Claxton can assist with the tubing cut and recovery, and then move forward with the perforation of the casing strings, flushing of the well, and subsequent cementing operation. The integrity of the cement plugs will be verified by pressure testing. Wellhead preparation. The Christmas tree can then be removed along with the annular wing valves. The tubing bonnet would then be removed so that a sacrificial joint that we can provide can be bolted on top of the wellhead. This will allow us to grab onto the wellhead for severance verification and the recovery stage. Severance. For the severance and recovery phase, Claxton will construct our recovery system on the deck of the installation. It is made up of a brace pair of spreader beams which span the main skid beams of the platform, onto which is positioned the work platform, which has a false rotary table. 4 hydraulic cylinders are suspended from the work platform, from which is hung a Claxton proprietary tension ring. The combined pulling capacity of the hydraulic cylinders is 200 tons, which is more than enough capacity to deal with the majority of the wells that we encounter. The well will be severed typically between 3 and 5 metres below the mudline, and be achieved through the deployment of Claxton's Sabre abrasive slurry jet system, which will cut the well from the inside out. Sabre utilises high pressure water, which is mixed with garnet. The high pressure slurry is pumped down hole to a hydraulically controlled cutting manipulator, where the high pressure slurry is accelerated to transonic speeds within the cutting nozzle to form the cutting jet, which slices through metal and cement with ease. We have a range of cutting manipulators available, which can be deployed in casing sizes as small as 6 5/8 inch. The Sabre system can cut through multi-string wells up to and including 30-inch conductor. And Sabre is also very effective at cutting wells with eccentric casing strings, more so than traditional cutting methods such as knives. Before cutting the well, an overpull is applied, typically between 60 and 100 tons, to assist with the cut and to provide positive verification. The cut will commence and be done in a single pass, taking approximately 6 to 7 hours. When cut, the overpull would drop off to the weight of the severed casing string, indicating a successful cut. The cutting manipulator would then be recovered, and operations moved on to the conductor recovery phase. Recovery. The conductor is hoisted up, and when the cylinders have been fully stroked, is landed off on the false rotary table, held with slips and with a safety clamp fitted for added security. The tension ring is then released and repositioned and reset. The lifting process can then be restarted. The process is repeated until the desired length and conductor to be cut, which is usually dependent upon the lifting capacity of the platform crane, is above the false rotary table. This is suspended from the platform crane. The conductor is then drilled with our double drilling units and then pinned with 4-inch pins in 2 places. The conductor is then cut with casing bandsaws, and the cut joint is then laid out. Once it is on the deck, debris caps will be secured to the open ends of the conductor before the joint is backloaded onto an awaiting vessel. This process is repeated until the conductor has been fully recovered, and the work platform can then be repositioned over the next well to be abandoned. Okay, let's have a look at a case study. This is for the Cameron Alpha platform in the southern North Sea. The operator required a rigless approach to abandoned wells on a normally unmanned installation. The self-skidding recovery deck modified to suit the limited deck space. It saved time moving between wells as it could be moved under its own power. The Sabre abrasive cutting effectively dealt with the eccentric casing strings, and crews were shuttled back and forth to the platform, enabling 24-hour working. Benefits to the operator included successful abandonment of 6 multi-string wells and no requirement to mobilise a jack-up rig.
I would now like to cover subsea wells. So what are the typical stages of a subsea well abandonment? Firstly, there will be the temporary abandonment or TA cap removal. The TA cap will have to be removed in order to gain access to the wellbore. This can simply be a can covering an H4 connection of a subsea wellhead, which would typically be removed by the vessel's crane with assistance from the ROV. Or, with the mudline suspended well, the TA cap would be screwed into the first casing hanger. For this type of cap, Claxton would deploy its temporary abandonment cap removal tool. This tool is deployed from the vessel's crane and lowered into the well until it lands onto the TA cap and the top of the conductor. The tool is then operated hydraulically, rotating its spindle, which backs out the TA cap, which is retained for safe removal up to the surface. This particular tool can be extended to recover caps 30 metres below the top of the conductor. We would then install a guide cone. This would be installed onto the wellhead and ensures ease of access when running the Claxton suspended well abandonment tool, or SWAT as it is known, into the well bore. P&A. For the casing perforation and cementing operation, SWAT is utilised. This award-winning tool provided an alternative to using rigs for the abandonment of subsea suspended wells since it was first deployed in 1996. The system permits perforation, circulation and cementing of multiple casing annuli whilst maintaining appropriate pressure control barriers. With 2 sets of inflatable packers and casing perforation guns, this tool can isolate, flush and cement individual well annuli. The SWAT tool is also able to verify the integrity of the cement plug by pressure testing. This is done all within the same deployment. The tool was recently upgraded with an extension module which enabled the setting of deeper cement plugs. In a recent campaign, the lowest cement barrier was displaced to 2,400 foot, or 730 metres below the mudline. I would like to mention that the SWAT extension model was developed and designed by Claxton's own R&D department and was manufactured on extremely fast turnaround, which is an excellent example of how reactive and innovative Claxton is as a company. Severance and recovery. For the wellhead severance, Sabre abrasive waterjet system is utilised. It is deployed in conjunction with our wellhead recovery tool, which is clamped onto the wellhead. Whether it's a mudline suspended or subsea, into which the Sabre cutting manipulator is landed off. The cutting depth is again determined by industry regulations and is typically 3 to 5 metres below the mudline. Before cutting, an overpull is applied to the wellhead for cut verification purposes. And when the cut is completed, the cutting manipulator is withdrawn and the wellhead is pulled out of the seabed and recovered up to the surface. Okay, let's look at a subsea well abandonment case study. This is for a recent campaign last summer. It was a multi-operator abandonment campaign in central North Sea for Centrica and Antrim Energy. 10 Cat 1, 2.1 and 2.2 wells were abandoned with this rigless method. As I said earlier, the new extension module enabled plugs to be set 2,400 feet below the mudline. The benefits of using SWAT include fast transition times between multiple wells on a single campaign. Typical well intervention times were between 36 and 60 hours. And multi-operators, and by having a multi-operator campaign offers the ability of sharing project costs. So now I'm going to cover rig-based abandonment. So what's involved? In some instances, the rigless approach for platform well abandonment is not appropriate. As a platform, for a number of reasons, the installation might just be too small, or the structural integrity might not be sound enough for the deployment of the required deck equipment. or the crane capacity could have been reduced to such an extent that handling equipment would have been impossible. In these cases, the decommissioning activities would have to be carried out using a drilling rig. The process of the actual well abandonment is similar to what was described for the platform-based decommissioning, but with the advantage of having the availability of a drilling derrick. So the first stage will be the P&A. The plug-in abandoning phase will be done by the rig. This will often involve section milling of the casing to ensure a rock-to-rock cement plug at the reservoir and the intermediate, and possibly surface barriers as well. Claxton will liaise with the client to ensure that the cutting recovery equipment is ready and can be mobilised quickly to fit in with the P&A schedule to minimise the possibility of any downtime occurred by the rig. Wellhead preparation. Again, Claxton can assist with the preparation of the wellhead, Christmas tree disassembly and wing valve removal, and we also offer on-site machining services. On a recent campaign, the structural integrity of the 24-inch conductor was questionable, and Claxton engineered a bespoke collar which was clamped around the conductor just under the starter head, through which we were able to drill and partially pin the conductor to the inner 16 and 13 and 3/8 casing strings. This allowed the distribution of loads applied to the well from the recovery process spread across the inner strings. By partial pinning, the inner well bore was left unobstructed. This allowed the running of the sabre cutting manipulator. Claxton also supplied the surface riser and crossovers required to connect to the wellhead. We were then able to apply tension to the well via the rig tension system and a Claxton proprietary tension ring. This freed up the drill floor for running the abrasive equipment. The severance phase. The cutting operation is the same as previously discussed for the rigless abandonment, other than the well being pre-tensioned by the rig. It is worth mentioning that the Sabre is a modular system which can be adapted to suit most deck layouts, and it's also been designed with the speed of assembly in mind in order to save costs. Once the conductor has been cut, it is then picked up via drill pipe with a Claxton riser handling tool, and when the wellhead is up past the rotary table, the conductor is held in slips before being drilled and pinned and cut with a bandsaw before the first recover joint is laid out. Link bars are then attached to the pinned conductor and shackled to the bales, and the conductor is then lifted for the next drilling and pinning operation to commence. Okay, let's look at a rig-based abandonment case study. This was a multi-platform well abandonment program in the southern North Sea. The operator had a requirement for a large number of wells to be abandoned across multiple platforms using a jack-up rig. Claxton supplied services included wellhead deconstruction, surface rise assembly with crossover spool, tension ring, on-site machining on wellhead, Sabre abrasive cutting, conductor pinning and cutting equipment. The benefits to the operator included a seamless service for multiple aspects of the abandonment program, ensuring minimal rig downtime. Okay, simultaneous operations. So what are the main disadvantages of using a drilling rig for well abandonment? The disadvantage of using a drilling rig is primarily cost. This can be from a high initial mobilisation cost or day rate. And also the critical work path of the rig always involves using the rig floor. And it's also time consuming to skid the drilling package from well to well. So at Claxton, we asked the question, what if we removed operations not specifically requiring the rig floor? Using a hybrid approach, utilising the rigless recovery frame and work platform on a multiple well installation would give us access to offline wells to perform non-critical operations such as wireline activities, casing perforating and cutting, bullheading, circulating seawater, circulating cement, Christmas tree and wellhead work, pressure testing, cement bond logging and tubing pulling. So whilst these have been undertaken from our work platform, the drilling rig can focus on critical operations such as section milling, circulating cement through drill pipe, scraper runs, casing tubing recovery, BOP installation. Okay, to work a simplified cost-time model, Claxton have used a client's well program with real-time figures from an actual abandonment of the well. The actual data shows a total time of approximately 400 hours per well, and with the Claxton proposed work split, this equated to 300 hours, which could be completed by either the rig or Claxton work platform, or 100 hours solely by the rig. This table showing the model for a 2, 3 and 4 well program as per the common Southern North Sea platform configuration. The table is a simple comparison of the time accumulation of multiple well campaign, with phase 1 being the non-critical rig floor tasks and phase 2 being the critical rig floor tasks. With the correct work scheduling, we believe time saving of 38% may be achievable. I have covered quite a lot today. I just wanted to summarise on the benefits of working with Claxton. We have an extensive knowledge and experience of well decommissioning projects around the world. Our tools and processes have defined rigless and rig-based decommissioning and have a proven track record. Claxton have continually invested in our team and proprietary tooling, with the result that today the company has completed over 280 cutting recovery projects, over 85 wells cut, and over 130 suspended wells abandoned. We define our unique offering as one that considers best practice that can be applied to different stages of decommissioning process, with a complete service from the P&A, wellhead deconstruction, abrasive severance and conductor recovery. We are also able to draw from interconnected disciplines from across the acting group of companies and third-party partnerships for specialist analysis work and manufacturing and machining where required. This enables us to define a full service offering for projects on a case-by-case basis, looking beyond intermediate short-term efficiencies and thinking more strategically of ways to reduce costs in the long term. We look forward to helping you with your decommissioning project very soon.
Thank you, Tom. I hope you found today's presentation useful. As mentioned before, if you have any questions about today's topic or other areas of interest, please submit your questions to info@claxtonengineering.com. If you'd also like to receive the latest information and news from Claxton, or subscribe to the Claxton Thought Leadership blog or monthly newsletter, please visit claxtonengineering.com. As well as a number of case studies and technical papers on our site, we have also just launched our free new decommissioning buyer's guide, so feel free to download this from the site as well. And of course, please follow us on our social media channels, including LinkedIn, Twitter and Facebook, to keep up to date with the latest information from Claxton. To close the webinar, please exit by clicking the file and exit. Thank you again for attending today's session, and we look forward to seeing you at our next webinar.